series of podcasts.
Hello everybody. It gives me great pleasure in introducing our speaker for today's podcast. Dr. Jay Asandi is Principal Research Scientist at CSTEC. He heads the Security Studies Research Group and is involved in the development of decision support platform for public policy problems. Dr. Jay holds a PhD and MS from Carnegie Mellon University, and his primary interests are in information technology for development. Jay, what is decision analysis and decision theory in your opinion?
All entities, humans, organizations, animals, make decisions in the conduct of their day-to-day lives. There are certain norms, axioms, guidelines that govern the decision that they will make in the choices that they are faced. Decision analysis explores the paradigm where a decision maker or a unit, could be a business unit in an organization, examines the choice of action in an uncertain environment. The prescriptive approach to this exploration is termed decision theory. According to Ralph Keeney and Howard Reifer, the pioneers of decision analysis is the prescriptive approach designed for normally intelligent people who want to think hard and systematically of some important real problems. What decision analysis tells us is how people should make decisions and not how they make the decisions. Now, how they make decisions is a related area of study called positive or descriptive discipline, and it attempts to describe what people actually do given the decision scenario. Since people usually do not behave in ways consistent with certain axiomatic rules, they violate the assumptions of the prescriptive approach, and this has led to the development of an area called behavioral decision theory. In this conversation, I think we will discuss only the prescriptive approach or the prescriptive aspect of the discipline and not the descriptive aspect.
So, would you agree that it is hard to make decisions?
Well, there are a number of reasons that decision making is hard. There are many reasons, and let me just get to four important reasons. The first important reason is that there are inherent complexities or there are inherent uncertainties when it comes to making decisions and the likelihood of the outcomes. The second reason is that there are inherent complexities in the problem itself. There could be many interlinked parts to the problem, and they are very hard to grapple simultaneously. The third reason is that there could be multiple objectives, that they may be very difficult to work together, that they actually lead to opposite outcomes and they lead to trade-offs, that is, the increase in one could lead to the decrease in the other. And the last one could be that the valuation of the outcomes themselves are subjective, which lead to multiple perspectives on the particular problem. And this is particularly important where groups are making decisions. Hence, decision theory is a multidisciplinary subject. There are aspects of operations research, there's systems analysis, there's management science, there's economics, there's decision and control, and there's also cybernetics given the computational capabilities in decision making today.
Dr. Jay, can you give us an example of a decision problem with such complexities?
Okay, so let me start with a very simple example to address the first part of the complexity, which is that of uncertainty. So a classical problem that we look at is that of hosting a party, and it's called the Stanford party problem. And we have two choices. We have the choice of having a party in the lawn outside, or we could have the party indoors. Now, each of these choices have their own benefits and hence a value given the outcomes. The uncertainty that we are considering here is that it might rain. Now, having a party on the lawn when it's raining is actually a non-starter. It's something that we would not like to have. Our guests would not like getting wet. At the same time, if we have a party indoors when it's nice outside, it's such a waste of good weather. So we have this fundamental problem that we have uncertainty when it comes to rain, and we have the choice of whether to have the party inside or outside. Now, if we know the probability of rain, that there is a possibility that it will rain, or hence it could be sunshine, we can compute what is known as the expected value of our decision. Now, this decision probability, so let us take for example that the probability of rain is just 30%, and the payoff or the value of having the party outside at that point in time is 10,000 rupees, and it is 0 if it rains, because no one would like a party when it rains and we are outside. Similarly, so the expected value of this particular decision will become 70% times the 10,000, which is 7,000 rupees. Similarly, the payoffs from having the party indoors, we can calculate the expected value from the decision. So let's say if the value is 6,000 rupees for if it is sunny outside but we are only inside, and it is actually 4,000 rupees when we are inside and it is raining outside, we can compute the expected value that is between those two numbers, and we will see clearly that if there's a 30% chance of rain, we would rather have the party outside than be indoors, and we are willing to take that chance. Now, to analyze this problem, we use the concept of decision tree. It's a tool that helps us structure this particular problem and helps us analyze this problem from the perspective of the different payoffs.
So, is it true that we will always pick a choice with the highest expected value?
Now, that is a very good question. It is known that in any decision maker, if they were given the option of choosing a bet between a 50% chance of winning rupees 100 and a 100% chance of winning rupees 50, I think he or she will always choose the sure bet of getting rupees 50. Even though the expected outcomes or the expected value of both those decisions are approximately same. And this concept is known as a risk aversion. In fact, if the choice was given between 51% chance of rupees 100 and 100% chance of rupees 50, we will still choose the sure bet. And most individuals are risk averse, and they are more likely to opt for a certain outcome than an uncertain outcome. And to accommodate this aspect in our perspective or the decision making or how we should make decisions, we introduce the concept of risk aversion. And in risk aversion, we calculate the term called certainty equivalent. And using these certainty equivalents, we can then come up with what is an equivalent decision. And based on risk aversion, decision makers will always pick the option that is relatively less uncertain than certain. Risk aversion came about quite a while back based on these observations and decisions, and I think it is something that people use quite commonly in decision making.
But then, Jay, rupee 1 or rupees 50 is not much of a difference to choose from.
That is true. So while the prospect of losing rupees 10,000 may not be much to some people who, let's say, are worth a lot of money, it can mean a lot more to others. And for this reason, decision theory also accommodates the concept of, in utility theory, they accommodate the concept of normalizing the wealth of an individual. So someone, let's say, who is worth 100 crores may not worry so much about 100 rupees in decisions, while someone who probably is worth only about a few hundred rupees, 100 rupees may mean a lot to them. And this could alter the way in which they make decisions. So when using utility theory and normalizing for the wealth of the individual, you take into account some of these aspects, and it would call for consistent decision making irrespective of how much wealth the person has already got, and they will make these decisions based on it.
So Jay, in your opinion, what are the aspects of decision making for public policy?
So like we discussed the 4 problems, so we've already gone through the idea of uncertainty, and uncertainty is a very big part of decision making, and it compounds itself when we take into account public policy. So one of the things that comes into aspects is the idea of multiple criteria. In the example that I just talked about, we talked about sun being, or the weather being, the only criteria. But what if there were many other criteria, and each of these criteria start intruding upon each other, or they have effects on each other? And this leads to the whole area called multiple criteria decision making, where we have to take these multiple criteria and start thinking about how we value each of these relative to each other as well as in the absolutes. Now there are multiple viewpoints that come upon this whole idea of multi-criteria decision making. Another aspect in public policies is the inherent complexities of the systems. There are multiple working parts. Sometimes we do not have an understanding of how they work together, how they work with each other. We do not understand how they dovetail into each other, and we don't understand what happens when some aspect of the problem changes and how it impacts other aspects of that particular problem.
So my final question to you would be, Jay, what are we doing to help address these problems?
Well, this is an ongoing area of research. Decision support systems is one way in which we use the power of computation and visualizations to help understand, structure the problem, and take into account some of the aspects of uncertainty and help let the decision maker understand the source of these uncertainties. So in public policy decision making, an important aspect is collaborative decision making. We are building systems to help this collaborative decision making, help the decision makers come together to take a look at the problem or examine the problem from their multiple aspects. They each will have their own lens, they will have their own valuations. Use these valuations, use these multiple valuations to help understand the inherent uncertainty in the problems, how they work with each other. Another aspect that we add to this computation is the use of agent-based models for simulations. When a particular decision is to be made, this will help in the areas of complexities of the particular problems. Understand how the problem changes due to small changes in certain variables or certain aspects of the problem, and computation helps us understand how the problem is complex, how it is uncertain, how we can structure the problem, and the collaborative decision making will help come to some level of understanding or collaboration between, or a consensus between these various stakeholders, and come up with decision makers that may not be optimal in the real sense but satisfies the decision problem.
Thank you very much, Dr. Jay, for sharing your insight on decision theory, decision making and decision support systems for public policy.
Thank you very much.